Hello, this video is for textbook lesson 1-4. That's chapter 1, lesson 4. It is titled Comparing and Ordering Integers, where our objective is to compare and order integers. The vocabulary for this lesson is integer, negative integer, positive integer, absolute value, and opposite. So we start off with supercooled insects. It says that water freezes at 0 degrees Celsius, but some animals can resist freezing by producing a chemical that lowers the temperature at which the water in their bodies freezes. This temperature is called the supercooling point. Which of these insects listed in the table has the lowest supercooling point? So in our table we have two columns. Right? You have columns and tables, and you have rows. So in the first column, we have listed the insects. They are the Arctic beetle, gall beetle, goldenrod gallfly, snow flea, and the woolly bear caterpillar. I've never seen any of these insects before. The supercooling point, respectively, for each of them is -54 for the Arctic beetle, -35 for the gall beetle, -9 for the goldenrod gallfly, -19 for the snow flea, and -7 for the woolly bear caterpillar. So the numbers in the table, they are negative integers. And by integers, we have the definition for it here. The integers are the numbers -3, -2, -1, 0, 1, 2, 3. However, you'll notice these dots here and the dots here. These indicate that the numbers continue without end in both the positive and the negative directions. So we're talking about over here, it would go on forever, -27, -57,203, -1,129,372, and just on and on and on, going to this end. Then over here, all the positive numbers, these dots mean it goes on to infinity. Big numbers in the trillions, gazillions, right? Whatever, however high you count. But the key is that they're non-decimal numbers. They fall right on the number line here. Where these tick marks are, those are integers. The stuff in between, those are decimals, and we'll learn in another lesson what we call those. But for now, we're focusing on integers. So negative integers are the integers that are less than 0. So over here, this red, everything to the left of 0 on a number line is less than 0, and these are the negative integers, and positive integers are the integers that are greater than 0. Everything to the right of 0, these are all the positive integers. Now 0 itself is neither negative nor positive. 0 is just, well, 0. So with that in mind, example 1 shows graphing and ordering integers. So to determine which insect in the table has the lowest supercooling point, we could graph the integers on a number line. So we'll start graphing them out, and we have 0 here. Everything to the left is negative, and notice that all of our temperatures that we were given are negative, so it makes sense that they are all to the left of 0. And the numbers get like, you think like they get higher as you go down, like 10, 20, 30, but it's actually -10, -20. So we'll talk about absolute value and opposites in a little while, so I don't want to talk about that too much. Just if we graph these out, -9, it comes as you go from the right going left, comes right before -10, -19 right before -20, -35 would be right in between -30 and -40, -54 would be just a little bit before the midpoint of -50 and -60, and then of course -70 would be right on -70. So we read the numbers from left to right as -70, -54, -35, -19, and -9. So this is the order from least to greatest. So the number in this list here, -9, is the greatest number. Even though it's negative, it's still the greatest there because, well, there are no positive numbers. So our answer is that at -70 degrees Celsius, the woolly bear caterpillar has the lowest supercooling point. So let's look at our checkpoint here. We could use a number line to order these integers from least to greatest. So I'm going to go ahead and grab a line here. We'll just kind of rough this out a little bit. Let's put this here as 0. We'll call that 0. And then let's start working. Let's do the negative ones first. -8, -4, and there's 0. We got that one taken care of, right? So we could put a dot here, graph 0 there. And then let's do the negative ones. Well, -4. We'll throw a -4 right there. And then -8, well, that's twice as much as -4, so it should be about twice the distance. So that would be twice the distance from 0, that is. So -8 would be right about here. And now we just have positive numbers, 5, 2, and 6. So let's see, 2 would be right here, right? And then if we graph out 6, 2, 4, 6 should be right about here. Graph that in. And then next, oh, we got 5. So 5 would be right about here. 5. So we have them -8, -4, 0, 2, 5, and 6. And that was listed least to greatest. Moving along, we're going to talk about a concept that is known as absolute value. The absolute value of a number is its distance from 0 on a number line. So if we plot a point on the number line, the question becomes, well, how far is it to 0? The absolute value of a number that we'll call A is written as absolute value A. And we're going to use these two lines for this. This is absolute value notation, and we read these two lines as the absolute value of, and then we just say whatever's in the middle. So let's talk about my memory device for this to try to teach the notation for this. Now, if you look at this, this is 0, and here's 5. Well, you got like the distance from here to the distance to here. So it's kind of like we're saying from here to here. Or likewise, for -7, you've got this here, and here's 0. So we're talking about the distance from here to the distance to here. Like, say, the distance between, well, these two lines, or the distance between these two lines. And so if you think of it that way, as distance between these two lines, well, whenever we're talking about distance from 0, we're talking about absolute value. So that's just kind of a memory device to recognize this notation as absolute value, because it's all about the distance from 0. So let's go ahead and I'm going to erase all the notation there. Erase my annotations. Good. And you can use a number line to find the absolute value of a number. So state the absolute value of the number. Well, for 5, if we plot 5, how far is it from 0? Well, it's 1, 2, 3, 4, 5 units. So the distance between 5 and 0 is 5. So the absolute value of 5 is equal to 5. Now for problem B, we see it's -7. So if we plot -7, we'll see that it's 7 units back here to 0. So the distance from 0 to -7 is a +7. So we would read that as the distance between -7 and 0 is 7. So the absolute value of -7 is equal to 7. And the reason that the number is always positive is because absolute value is all about distance. And distance can't be negative. I might say, walk a -5 feet. Well, you might walk backwards 5 feet, but you still went 5 feet from where you were. It's impossible to have a negative distance. I threw the ball a -3 feet away from me. You can't do it. It might be a different, you might have one direction to your right and one to your left, but the ball was still thrown 2 feet away from you. Now, hopefully you can throw a ball further than 2 feet, but nonetheless, that's my example. So, the absolute value is always positive. Now, you might just look at it this way. Whatever the number is inside between the absolute value signs, it just comes out positive. If it's positive, it stays positive. If it's negative, then it becomes positive. Either way. Looking at the next section, we have opposites. So, two numbers are opposites if they have the same absolute value, but different signs. For example, -10 and 10. Their absolute value is 10 for both of them, but one has a negative sign, the other one's positive. so they are said to be opposites. The expression negative 10 can be read as the opposite of 10. So instead of saying negative 10, I could say the opposite of 10, because the opposite of 10 is negative 10, right? The expression negative a, or opposite a, or negative a, because they want you to use opposite here. So the expression negative a is read as the opposite of a. So like the word negative and opposite, we can kind of switch them in and out and interchange them. So find opposites. State the opposite of a number. So here's 6. Well, 6 on a number line is 6 units from 0. The other 6, that's 6 units from 0, is negative 6. So the opposite of 6 is negative 6. And likewise for B, they want to know about what about negative 15? Well, we could actually say the opposite of 15. So the opposite of negative 15. Well, negative 15 is here. It's 15 units to 0. So if we keep going 15 units to have the other number that's 15 units from 0, we would get positive 15. So the opposite of negative 15 is positive 15. So opposites are like the same number, only one's negative and the other one's positive. That's the idea of opposites. And absolute value, it's all about the distance from 0. We just take the number and it comes up positive. Same number, it's just if it's positive, stays positive, it's negative, it stays negative. And then we take that idea of absolute value in order to make the definition of opposites. All right, so state the absolute value and the opposite of the number. So 3, the absolute value of 3, well, it's 3 units from 0, so it's 3. And the opposite of 3 is, well, it's the same number, only with a negative sign. So the opposite of 3 is negative 3. Absolute value of negative 1. Well, negative 1 on a number line is 1 unit away, so it's a positive 1. Negative 1, well, the opposite of that is the same number, but opposite sign, because they would be the same distance on a number line from 0. So the opposite of negative 1 is positive 1. And we'll jump over here to 5. The absolute value of 11, negative 11. Negative 11 is 11 units from 0, so it's a positive 11. And then the opposite of negative 11, well, it's the same value, only the same number, the same absolute value, you should say, but just with the opposite sign. So since this is negative, we're going to make this one here positive. Those are opposites. Evaluating variable expressions. So we're going to take this idea of absolute values and opposites, and we're going to plug that into a problem and work that out. So on this first one here, A, oh well, I better go back, right? And evaluate the expression when y is equal to negative 5. So whatever y is, we're going to make it negative 5. So opposite of y. So we can say opposite of y. What is y? It's negative 5. So even though 5 is negative, this here's a negative 5, we're going to put it in parentheses. A good practice is take whatever they give you, rewrite it, right? But whatever the y is, or whatever the variable is, put it in parentheses. So we have minus sign and then in parentheses negative 5, because that's what y is. We get to read this as the opposite of negative 5. Read the negative sign as the opposite of. So we just say the opposite of negative 5 is positive 5. Here on the next one, we're going to plug in the 5, negative 5 here. So they say 17 minus the absolute value of y. So we'll rewrite this, 17 minus the absolute value, and what is y? It's negative 5. Now we'll bring down the 17, bring down the minus, and what is the absolute value of negative 5? It's positive 5. Then we just do 17 minus 5, and we get 12. All we did was we just took whatever y was, and we plugged it in to the equation. For checkpoint, let's go ahead and do a couple of these. So it says the opposite of x. So opposite of x. What is x? Well, it's negative 4. So I'm going to plug in negative 4. Now I'm going to read this as the opposite of negative 4. What's the opposite of negative 4? It's positive 4. So in this case, the answer would be 4. Let's jump over to absolute value of x plus 9. So we're just going to substitute in what x is, negative 4. Bring down our plus 9. The absolute value of -4 is +4. It's like the number jumps out, but it becomes positive, right? Because -4 and 4 are both the same distance from, you guessed it, 0. Now put +9, bring down the +9, and 4 plus 9 is 13. So our answer for 8 would be 13. Looking at the guided practice, a little check off here at the end before we move on to our activities. Which of these numbers is not an integer? Well, we know those are the numbers. Integers are the numbers that, remember, fall on the number line here. So they have to fall on these hash marks on the number line. So anything in between here is not an integer. So these are like where all the decimals live, like, oh, I don't know, 5.5, right? Which would be right there in the middle. So if we go back and look at those problems, looking for the ones that have decimals in them, we see that this one here is. So this one's not an integer. -31 and -7, those are negative integers. And 74 and 19 are positive integers, non-decimal numbers. Explain why the absolute value of a number is never negative. Well, absolute value is all about distance, right? Distance can't be negative. That's why absolute values are never negative. Write the integers in order from least to greatest. So if we put a number line here, and let's throw 0 on there, and sure enough, 0 is one of them. Let's go ahead and do the positive numbers first. I got 6 and 12. So I can put 6 here and 12 here. And then I have a -3. That'd be right about here. And then a -5. So I took care of -3 and -5. Well, I'm really going to get tight here. Oh, we'll put it up here. -5 there. And then -9, which would be right about here. So from least to greatest, reading from left going right would be -9. We use a comma to separate them. -5, -3, 0, 6, and 12. Absolute value of each number. So absolute value of 1 equals 1. Absolute value of -9 equals 9. Absolute value of 15 equals 15. And the absolute value of -12 equals 12. It's just the same number. It just always comes out positive. What's the opposite? So we're going to write the same number, but change the sign. So 14, opposite's -14. 33, opposite of positive 33 is the opposite of -33. What's the opposite of -24? 24, it was negative, now it's positive. And what's the opposite of 81? Well, let's write the 81, throw a negative sign in front of it, -81. And then finally, evaluate the expressions when x equals -3. So I'll go ahead and let's try 13 here. So let's rewrite this. And notice I've rewritten it the same down here as I did here. Only the thing is where x is, I'm going to put in -3. So I have absolute value of -3 is +3. Absolute value of -1 is +1. And 3 plus 1 is indeed 4. They want to know about error analysis. I'm going to erase this a little bit so we can read through the directions there. Error analysis. Describe and correct the error in evaluating the expression absolute value of -17. Well, this is wrong. Why? Well, hopefully you've noticed they gave a negative answer. And this is all about absolute value. Notice the bars from this from here to there, you might say. It's all about distance. Distance can't be negative, so in that case, it would have to be +17. All right, so those are all of my examples and discussion for Lesson 1-4. It was titled Comparing and Ordering Integers, where we learned to compare and order integers.